Hey students, today we're going to talk about KMT. KMT stands for Kinetic Molecular Theory, which states that particles of matter are always in motion. In this, we'll talk about an ideal gas. An ideal gas is an imaginary gas that perfectly fits the kinetic molecular theory, and that is, there's no true gas that's actually ideal, but there are some that are more ideal than others. So what is the complete theory? So these five are the assumptions that have to be true according to the kinetic molecular theory. So gases have large numbers of tiny particles that should say R, far apart relative to size. Average kinetic energy depends on temperature. So that means higher temp equals more kinetic energy, okay? Elastic collisions, that means there's no net loss of kinetic energy. So when those gas particles hit each other, they're going to not lose any of the kinetic energy that they have. The fourth postulate is that gas particles possess kinetic energy in rapid continuous motion, so they're constantly moving, but they're not moving in a general direction. They just kind of go in a straight line until they hit something, and then they bounce off and go in another straight line until they hit something. No forces of attraction or repulsion between gas particles. This would be the biggest one that real gases don't do. So, expansion. When expanding a gas container, the gas will expand to fill the container. Fluidity. Gases are fluid, kind of like liquids. They're fluid, the continuous random motion. They all have low density, so small mass in a very large volume. You have compressibility. Gases can compress to fit a small container. And then two new words, well, one of them might not be new. Diffusion, I believe you heard in biology. That's spontaneous mixing of particles of two substances by random motion. And then we have effusion, which is a process where gas particles pass through a tiny opening. So a real gas is one that does not behave completely according to the kinetic molecular theory. Usually, polar gases more act like real gases, and non-polar gases act like ideal gases. And the reason why is because the non-polar have less, apparently I can't spell less attractions to each other. If you remember back to first semester when we had something like H2, this was nonpolar, and then we had something like H2O, and this was polar. Well, this one had stronger interactions. This one had had H bonding. This one had LDF, and so this has little attraction. This one has more attraction, and so if you're going back to here, the no forces of attraction or repulsion between gas particles, because this one has little attraction, it's going to behave more ideally like that for that KMT. Pressure is force divided by area. Atmospheric pressure, which is like your sea level, your pressure at sea level, is 1 atm. It is measured with a barometer. You'll hear that on the weather. Here's your conversion units. Ones that are going to be needed will be given to you in the test. So we're going to have an example. We're going to convert 650 millimeters mercury to kPa. And so we're going to start with our 650 millimeters mercury. And once again, we're going to follow our units whenever we convert. So millimeters mercury needs to come down here. Okay, we want to get into kPa. So kPa is going to go up here. You need to look through and find these units. So millimeters mercury, I see that right here. The number in front of it is 760. kPa, I see right there. That number in front of it is 101.3. Then you want to multiply across, so 650 times your 101.3 and divide by 760. I get 86.6 kPa. Temper conversions, you want to use this. We're only going to be working with Kelvin or Celsius. Do realize that when you're looking at this, Kelvin does not have a degree symbol. I'll kind of show you down here. When you're looking at this, when you're looking at this, you just take your degree Celsius and add 273. I'm not going to go through an example because it's really simple. Standard temperature and pressure, which is STP, it's just a standard set of conditions. Standard temperature is 0 degrees Celsius or 273 Kelvin. Notice the Celsius has a degree symbol, Kelvin does not. Pressure is 1 atm.